Hi everyone. Okay, so today we're going to look at linear quadratic systems. So the first thing you need to know is to be able to tell the difference between a line and a parabola, which kind of function is going to give you which. Notice how this has an x squared. That makes this a quadratic function. When you graph a quadratic, you get a parabola that looks like this. It's got a little U shape to it. Okay. Notice here, you just have a y and an x. Nothing is squared. That's a linear function. So if you look at number 3, as soon as you have an x squared, you have a y and you have an x squared. That makes it quadratic. And in 4, there's no squaring, so it's going to be linear. But this one, not only is it linear, this one is a horizontal line. And we're going to talk in a minute about how you'll tell when a line is going to be horizontal. So we're going to review first some things about lines. Remember, I think everybody's favorite form of the equation of a line is the slope-intercept form, y equals mx plus b, right? Everybody likes y equals mx plus b, where m is the slope. That tells you how to rise over run right. And then b is your y-intercept. When you try to graph, you begin with B on your y-axis, okay? Now, a horizontal line is when you have an equation y equals a number. Now, the way that I remember the difference between my horizontals, see, my horizontals is y equals a number and vertical is x equals a number. The way to tell that, a horizontal line has to hit the y-axis. That's how I know it's y equals a number. If you have, here's an x in the y-axis again, if you have a vertical line, it has to hit the x-axis. That means it's x equals a number. That's how you tell the difference in the equations, okay? Now, quadratics are when you have a y and an x squared. You may or may not have the x or the c. Remember we did this in the last unit when we did the quadratic formula. We had to have everything in the form ax squared plus bx plus c equals 0. Now instead of equal to 0, it's equal to y. So that's when you have a y and you have an x squared. That's when you know you have a quadratic. That'll give you the graph of a parabola. What we're going to do is we're going to have a linear function and a quadratic function, and we're going to graph them both. And to solve this system, we're looking for the points that both graphs have in common. We're looking for their points of intersection, okay? So when we go to graph, when you have a linear function y equals mx plus b, you have to find b, the y-intercept, and plot it on the y-axis. You plot that point. Then you find the slope m, and from B, you rise up the top number and run right the bottom number. Connect the dots with a straight line, put arrows on the line, and label it with the equation. Please do not make me take off points because you didn't label the equation, okay? Next, when we have the quadratic, you're going to use your calculator. If you're at home and don't have a calculator, use Desmos on your Chromebook. And you're going to make a table. Now, the trick is when you have the table, the vertex has to be in the middle. That vertex is your turning point. It will either be a maximum or a minimum. You have to find that point and put it in the middle of your table. Then for the x values, you're going to pick 3 x values smaller than that x and 3 values bigger. You're going to use Control T on your calculator to get the table, and we'll go through this, to get the table, and you're going to copy the numbers out for the table. Then you're going to plot the points. Make sure you plot them, that you're not just saying, oh, it looks like this. No, plot the points and then connect with a smooth, rounded curve. No straight line segments, no sharp corners, okay? Again, arrows on the parabola and label with the equation. Do not leave that stuff out. Okay, let's take a look now. So here's an example. Y equals x squared minus 6x plus 6 and y equals x minus 4. let's do the line first. If we have y equals x minus 4, remember that's y equals mx plus b. M is the number in front of the x. If we don't see it, it's an invisible 1. And of course, it's over 1 if you ever have an integer. So even if it was a 2x, it'd be 2 over 1. So that tells us we're going to rise 1 and we're going to run right 1. Now the y-intercept, that's the b, that's the negative 4. So when we go to graph this, we go to negative 4 on the y-axis. We go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. As soon as you have a few of them, then you go get your handy dandy straight edge. Don't forget to put the arrows on it. Okay. Don't forget to label it with the equation y equals x minus 4. All right, now we have that one graphed. Now let's take a look at our parabola. Y equals x squared minus 6x plus 6. We're going to make an xy table, but in order to do that, we need to go get our handy dandy calculator. Okay, so let's jump to the calculator. Okay, so we're going to open a new document. We're going to add a graph page. So we have as our quadratic x squared minus 6x plus 6. And we hit enter. There we go. There's our quadratic. We want to find the turning point, that minimum here. Notice because this parabola opens up, this is a minimum. So to find the minimum, we go to Menu, Analyze Graph, and we're going to choose Minimum. We move to the left of the minimum. See where it says lower bound? We're going to go to the left and click. Then the upper bound, we move to the right and we click. And there's the minimum. So our minimum is at 3, negative 3. So this number 3 is going to be in the middle of our table. So we're going to have 3 in the middle of the table, and we're going to have to use 3 numbers smaller than that, 2, 1, and 0, and 3 numbers bigger than that, 4, 5, and 6. Now, how do we get the table? There's 2 ways. If you hit Menu, choice 7 is table, and we're going to choose split screen table. Now notice here in parentheses it says Control T, so you can either click on that, but if you remember the shortcuts, if you just hit Control T, it'll give you the table, and if you hit Control T again, the table will go away. So we want the table. We said we need 3 in the middle, and we need to go 1, 2, 3 bit smaller than that. So our table has to start 0, 6, 1, 1, 2, negative 2, 3, negative 3, 4, negative 2, 5, 1, and 6, 6. So now you're going to copy that information down onto your paper. Okay, so on our calculator, we saw that the vertex was at 3, negative 3. We take 3 numbers smaller than 3. That's 2, 1, and 0. And 3 numbers bigger than 3, 4, 5, and 6. And the numbers we copied off the table. Now we're going to plot those points. 0, 6, 1, 1, 2, negative 2, 3, negative 3, 4, negative 2, 5, 1, and 6, 6. Now the best we can do, making a smooth, rounded curve so that we have, have this parabola, arrows on it, and then write that equation, y equals x squared minus 6x plus 6. Okay, we've done the work, and now we can find the solution. Now the solution is where the graphs intersect, and some of us can see it right here, all right, where we have those 2 points that are circled, and that the first one is the point 2 comma negative 2, and the other one is the point 5 comma 1. Now some of us tend to switch our x and our y values, so I'm going to also show you how to do this on the calculator. So let's go back to the calculator. Okay, so we want to find the points of intersection. So the first thing I'm going to do is get rid of the table. I press Control T. Now we need to put the equation of the line in. So in order to get back up here where we can type that in, we press Tab. Now we can type in the x minus 4 and hit enter. Now there are two ways to find these points of intersection. The first way, and a lot of teachers will show you this way, menu, analyze graph, intersection. And you go to the left of where they intersect and to the right, and it gives you the one point of intersection that was right there. Now the catch here is you now have to do the whole thing all over again just to find this other point. It's not a problem. You can do it. It's easy enough. There is another way. You can go to menu. Now remember, we're finding points of intersection. Go to menu, and this time go to geometry. And since we're looking for point of intersection, we choose points and lines, and then intersection points. You click on one graph, click on the other graph. See this symbol? I have to hit escape. So it's click, click, escape. And notice it gives us 1, 2. It's going to give you all the points of intersection at the same time. So now we have our points. Okay, let's try one more. Let's do the line first. Y equals 2x minus 2. Again, that's y equals mx plus b. So our slope is the 2, and we put it over 1 so that we rise 2 and we run right 1. The y-intercept, that's the b, that's negative 2. So on the y-axis, we start at negative 2. Now the slope is rise 2, run right 1. Up 2, right 1, up 2, right 1, up 2, right 1. Get that handy-dandy straight edge. Connect the dots. Draw arrows. Label with the equation. Y equals 2x minus 2. Now, let's try this parabola. Y equals x squared minus x minus 6. We have the x and the y. We're going to put this in our calculator. We're going to find the vertex, and then we're going to fill in our table. So we're going to add a new page, Control Doc. We want another graph page. Now we're going to put in our parabola. This time it's x squared minus x minus 6. And I'm going to press enter. First thing we want to do, remember, is find that minimum. So we go to menu, analyze graph, minimum, because we need that turning point. We go to the left, we go to the right, and there it is. So 1/2 or 0.5 comma negative 6.25. So this 0.5 has to be in the middle of our table. And then we're going to need 3 numbers smaller than 0.5 and 3 numbers bigger than 0.5. So let's get the table. We go to Control T to get our table. Now 1/2 has to be in the middle. 1/2 is between 0 and 1. So we have to go 3 numbers smaller than 1/2. 0, negative 1, negative 2. So here we're now going to start copying our table. Negative 2, 0, negative 1, negative 4, 0, negative 6, 2, negative 6, 4, negative 2, 2, negative 4, 3, 0, 4, 6. Okay, copy those numbers onto your paper. Okay, so we found that our vertex was at 1/2 or 0.5 comma negative 6.25. We needed 3 numbers smaller than 1/2. That would be 0, negative 1, and negative 2. 3 numbers bigger than 1/2, 1, 2, and 3. And I think we're going to need, and we needed one more. We're going to need one more. We're going to need to go all the way to 4. So negative 2 is 0. Negative 1 is negative 4. 0 is negative 6. 1 is negative 6. 2 is negative 4. 3 is 0. And 4 is 6. Now let's plot those points. Negative 2, 0. Negative 1, negative 4. 0, negative 6. 1/2, 6.25. Plot. Now here's why originally we only would have plotted this far. Okay, but I see one point of intersection here, But it looks to me like this is going to keep going and hit my line again, which is why I said, uh-oh, I'm going to put 4 into my table, because now when I put 4, 6, now I can see where that other point of intersection is. So now I can see this other point of intersection, and now I have my solution at the points, let's see, this was -1, -4, and then that was the point 4, 6. Make sure that your points are written in parentheses, otherwise they're not points. We will go to the calculator, make sure you're okay finding those points of intersection, and then we're good. So now we're going to turn off the table, Control T again. Now we're going to tab up so we can put in our line, which was y equals 2x minus 2. Hit enter. I'm going to use the geometry menu to find those points of intersection. I'm also going to move my equations out of the way. I'm going to go to Menu, Geometry, Points and Lines, Intersection Points. Rewind it if you need to watch it again. Click on the parabola, click on the line, escape to get out of it. So I have a point here at 4, 6, and I have a point down here at -1, -4. There we go, guys. All right, hope this helped.